Hi to all. Welcome to my first class on chapter number 8, Introduction to Trigonometry. You have studied about triangles, particularly right angled triangles. I will give you some situations. What you have to do is, you have to imagine to form a right angled triangle out of these situations. Let us see it. Suppose you are going to visit Eiffel Tower. Now you are looking at the top of the tower. Can you make a right angle triangle out of it? Let us see it. You are looking at the top of the tower. Let me represent its height. This is the height of the tower. Now if you are looking straight to this tower, see, here you can find out a triangle, a right angle triangle. Can you find out its height without actual measurement? Let us see it later. Let me take another example. Suppose you are standing at the top of your house and you are watching a car moving towards your house. Here, can you imagine how to find out a right triangle from this situation? Now you are looking from the top to the car. Let us try it. Here you are looking to the car. Now let the height by another line segment you can make, and this car is moving towards your house. Here also you can find a right angled triangle. In all these situations, how can you find out the distance or the height of the tower without using actual measurements? Here we are using a branch of mathematics which is called trigonometry. Trigonometry is derived from three words. One is trig. Trig means three. And the other word is gon. It means, polygon and all. It means sides. And the third word is metron. These are all Greek words. Metron means measure. So trigonometry is derived from three words: trig, gon, and metron. It means three sides and measure. Yes. So trigonometry we can define as, trigonometry is the study of relationship between the sides, angles of a triangle. Trigonometry is widely used in every field of our day-to-day life, such as it is used in astrology to find out the distance between the stars and all. It is widely used in satellite mapping, engineering like civil engineering, electronics, architecture. In all field of science, trigonometry, the application of trigonometry is used. In this class, we can discuss how the trigonometric ratios can be found. Now, let me take three numbers. Let 3, 4, and 5. How many ratios can be made from these three numbers? Such as one ratio is 3 by 5, another ratio 4 by 5, and one more ratio, can you say? Yes, it is 3 by 4. Now take the reciprocal of each. Again you will get three ratios: 5 by 3, 5 by 4, or 4 by 3. That means if you get three numbers, you can make 6 ratios. Now let me take a right angled triangle. Let the triangle be ABC, right angle that B. Now, let me take an angle C. According to this angle, what is the opposite side? It is AB. AB we can call it as opposite side. Then what about BC? It is adjacent to angle C. So this side we can call it as adjacent side. Of course, what is AC? AC is hypotenuse. According to angle C, AB is opposite side, BC is adjacent side, and AC is hypotenuse. Now, if I take angle A, this all opposite sides and adjacent side will be changed. Here, let me consider angle A. According to this angle A, can you say what is opposite side? Opposite side, it is opposite to angle A. Yes, it is BC. What is the adjacent side? Adjacent side you can say it is the side containing A, which is AB. And of course, what is hypotenuse? It is opposite to the right angle. So hypotenuse here, it is S. So according to the angle, adjacent side and opposite side can be changed, but hypotenuse remains same. Now, let me consider the last example. Here, what are the sides? Sides are AB, BC and AC. Now, by using these three sides, how many ratios you can form? Let me take one ratio, which is AB by AC. Can you write other ratios? Of course, next ratio we can take it as BC by AC, and the third ratio you can write it as AB by BC. Now take the reciprocal of these three, that is AC by AB, then AC by BC, and the last is BC by AB. Now look at the first one, AB by AC. According to angle C, what is AB? It is opposite side, and AC, it is hypotenuse. So AB by AC you can write it as opposite side by hypotenuse. Opposite side by hypotenuse. This ratio we can give a name, that is sine of angle C, or in short we can write as sine C. Now let us look at another ratio, BC by AC. What is BC by AC? BC is adjacent side and AC is hypotenuse. So BC by AC is adjacent side by hypotenuse, and this ratio we can call it as cosine of angle C. That is cosine of angle C, or in short you can write it as cos C. So cos C means it is adjacent side divided by hypotenuse. And the ratio AB by BC. AB by BC means AB, it is opposite side by BC is adjacent side, that is opposite side by adjacent side. This we can call it as tangent of angle C. Tangent of angle C, or in short we can call it as tan C. Now, what is AC by AB? AC by AB is hypotenuse by opposite side. That is the reciprocal of sine of angle C. Right? So, this you can write it as hypotenuse by opposite side, and this ratio we can call it as cosecant of angle C, or in short you can write it as cosec C. Now the other ratio is AC by BC, that is hypotenuse by adjacent side. This hypotenuse by adjacent side we can call it as secant of angle C. Secant of angle C, or in short we can call it as C. And the last ratio is the reciprocal of tangent of angle C, that is opposite side by adjacent sides reciprocal. So that we can write it as adjacent side by opposite side, and this ratio we can call it as cotangent of angle C, or in short we can write it as cot C. So these are all the trigonometric ratios in respect of an acute angle. Now look at the first ratio, that is AB by AC, and this ratio you can call it as sine of angle C or sin C. Now if you divide this ratio by the second ratio, that is BC by AC, that is cosine of angle C or cos C. Dividing the first ratio by second ratio, that is sin C by cos C. What will you get? This is AB by AC into reciprocal AC by BC. AC cancel. You get AB by BC. Now what is the third ratio? Yes, it is AB by BC. That means dividing sin C by cos C, you will get the third ratio, that is tan C. Or we can say tan C, you can write it as sin C by cos C. I will give you another right triangle and an acute angle. Can you define all these ratios? Here is a right angle triangle PQR, right angle that R. Now let me consider angle P. According to angle P, what is the opposite side? QR is the opposite side and PR is the adjacent side. And QP is the hypotenuse. Now my question is, what is sine P? Sine of an angle is opposite side by hypotenuse. So here it is QR by PQ. If it is so, write cos P tan P. Again, let me take right triangle PQR, right angle that R. Now let me take QR is equal to 8 centimeter, PR is equal to 6 centimeter. Then what is PQ? Of course, it is by Pythagoras theorem. It is square root of 8 square plus 6 square, that is square root of 100, which will be equal to 10 centimeter. Now, can you find out what is sine Q? Here, according to angle Q, opposite side is PR and hypotenuse is PQ. So, it is sine Q means it is PR by PQ. That is 6 by 10. You will get it is 3 by 5. So, sine Q is 3 by 5. Now, what is sine P? According to this angle P, Opposite side is QR and hypotenuse is PQ. So sin P you can write it as QR by PQ, that is 8 by 10, which is equal to 4 by 5. Similarly, you can find out any trigonometric ratios with respect to an acute angle P or Q. You can find out its value. Here is a question for you. Exercise 8.1. In triangle ABC, right angle at B, AB and BC are given. So you have to find out AC and then find out the value of sin A, cos A. Similarly, sin C, cos. Do use it. That's all for today's class. Have a nice day.